Okay, now let's get into the absolute configuration. Okay, so for this pair of enantiomers, okay, so these two enantiomers, there are two ways in arranging the atoms bonded to it. Okay, so the first way is A, B, C, D in this direction. Okay, the second way is A, B, C, D in this direction. So obviously these two are non-superimposable, right? So that's what makes them enantiomers. Okay, now let's get into how we can classify them as R and S. Say the first step to doing this is to uh, identify the order of priority of these atoms that are bound to the central atom C. Okay, so the order of priority depends on the atomic number of the atom. So if A has a higher atomic number than B, and B has a higher atomic number than C, and C higher than D, then the order of priority is A greater than B greater than C greater than D. So we can actually find this out using the periodic table, or if we already have a good knowledge of the periodic table, then that's not required. Now let's take a look at a real example. Okay, in this example, the first case, F, as we know as, Br has the highest atomic number, so this gets number one priority. Second is chlorine, third is fluorine, fourth is hydrogen. And in this case, it's the same thing. First, second, third, fourth. But in this case, if you try to indicate the order, it goes like this. And here it goes like this. So since this is moving towards the right, this is R configuration, and this, since it's moving to the left, this is S configuration. Do you get me? Okay, now let's look at another example. Look at this example. If you have to find the absolute configuration of this molecule, the first step would be to arrange them based on their priority. So let's do that. Okay, now let's try to find the configuration. What I told you guys to do is to find the order in which it goes. So there's 1, 2, 3 and 4, but this is completely wrong. So in such cases, when the order is not very obvious, we have to rearrange the atoms in this molecule in a way that 4 comes to the bottom. So for that to happen, we have to move 4 here, right? Move 4 here, and as a result, this 2 will move here, 2 will move here, and as a result, 1 will move here. So it's actually a anti-clockwise shift. So let's do that. Also, another thing to be noted is that you cannot move the topmost. So this guy, he cannot be moved at all. Okay, so now let's see. So fluorine moves here, hydrogen comes here, and chlorine comes here. So now this is 1, 2, 3. Okay, so now the fourth step, the next step is to eliminate hydrogen. Just cut it out, pretend as if it does not exist. Now just join the orders. Chlorine, fluorine, and the methane group, the methyl group. So now it comes this way. It's moving towards the left. So this is S configuration. Okay, now let's do this example problem. Pause the video and try it. Okay, I hope you got the answer. If not, I'll solve it for you. Okay, now this might look a bit confusing to people. What this 2 and 3 mean is that this is the second carbon and this is the third carbon. So we need to find the absolute configuration of the second carbon and third carbon and find the correct option. So for this, we would need to break this into two different compounds. So if this is the second carbon, this will be the first compound I'm breaking it into. So this will be CH3, Cl, and this will be this, and the bottom group will be this group. So let me take that as X because it's too much to write, and this is hydrogen. So obviously chlorine will be the first priority, and the second priority we have to choose between CH3 and X. So now let's actually see this third carbon. This starts with the third carbon and then breaks into a hydrogen and a chlorine, right? So this third carbon is the same as this methane molecule, but this is attached to only hydrogens, whereas this third carbon is attached to a chlorine as well. So that means, so because of that, this third carbon gets the second priority over the methane. Okay, now so methane is obviously about hydrogen. Okay, so now let me draw more clearer version. Chlorine, hydrogen, CH3, and this is the group X. 1, 2, 3, 4. Okay, so now as I said, we need to rearrange this in such a way that the fourth group comes down. So now let's move this here, and this here. So now the new rearranged molecule will be like this: X, H, Cl, CH3. 1, 2, 3. Now we cut this out, and now look at it. It's moving this way, so that means it's S configuration. So now we know 2 is S. Okay, now let's take a look at 3. Okay, 1 second. C2, H5. Okay. This is the third carbon, just for reference. C2H5Cl, and this is the second carbon here. Okay, so now again Cl will get first priority, and we have to choose between the second carbon and C2H5, but obviously the second carbon will get more priority since it's attached to a chlorine. So this is getting second priority, this is third, and this is fourth. So now we again rearrange in a way. So this time we keep 2 constant, we cannot move 2, okay, because that's the topmost position. So now in what way can we rearrange this so that H comes down? We move H here, so we move 3 here, and then we move 1 here. So it'll look like this: 2 H Cl and C2 H5. Okay, so this is the third, this is 1, this is 4. So now we cancel this, and now we do this. So even this is coming anti-clockwise, so this is also S. So the correct option is 2S and 3S. Thank you for watching.